let's go ahead and put our post-it in. And I would think all of you would agree that this is a graph like you could have had. You could have had this problem on quiz today, and I could have asked you what the domain and range is. I'm not so concerned with the range right now. It's a little messier than I might want it to be because it doesn't have any, yeah, actually I think some of them are arrows on that. You've got a bunch of open dots, and I started to change this one to a closed dot, but I think I'm gonna leave it like that because I'm thinking maybe you have one like that in classwork. But if I talk about its domain, is it all real numbers? Can you look at the x-axis and does every x have a y? Now that's not one of the questions on the classwork now, but we need to talk about domain and range a lot. Does every x have a y? Now these are arrows and they're kind of hard to see. If it is, it's all real numbers. With one exception though, look at the dots. And there's one x that actually doesn't have a y. It can't be -1. So you could say, if you want to write in words, you could say all real numbers except x can't be -1. Or you could say x is less than, x is less than -1, or x is greater than -1, but it can't be equal to it. So there's a couple ways you could say it. But what we're going to do today is we're going to evaluate. Now function notation is f of x. And f of x simply means it's equal to y. I mean, that's the easiest way to say it. That's another notation for y. And that's actually the way we're going to write it today. Let's start with this graph. And it's probably going to be easier to see on yours because this is kind of tiny. The number's a little bit small. But I want to actually know what is f of -2. What is f of 2? What is f of, if I can read my writing, f of -1 and f of -3. And the first one, and I'll show you the first one, what it's just another notation for. This is just and it's really a more organized way of saying what is the y when the x is -2, just like I did with the t-table or I did with ordered pairs. So we're going to actually write this one 3 different ways. Function notation, we'll do t-table, we'll do ordered pairs. What is f of -2? What is the y when x is -2? Well, go to -2 on your graph and tell me what the y is. Okay, you said it with a question mark. Are you saying, is it 1 or is it specifically 1? Do you know for sure it's 1? Well, let's see. Go to -2, go right there. What is that point? -2, 1, isn't it? Okay. You said it like you weren't sure. So it equals 1. And now what that means is if you did it as a t-table, oh, well, I did that, then the x would have been -2 and the 1 is y. I like it because it's written out as an equal statement. And we don't use equals with t-tables, and we don't use equals with ordered pairs. But it's this also. All 3 of those are interchangeable. My arrows can go both ways. All of these mean the same thing. And we tend to use this one a little bit more. That's probably what you're going to see on the ACT too. Let's run through the rest of them. What's f of 2? Okay, f of 2 is, now can y'all see it? Look at the graph. Kyle, what is the f of 2? Okay, +1? -1, thank you. F of -1, Jude? There isn't one, is there? So in this case, I just put not possible. I don't really want no solution because it's not an equation that you're solving. I just put NP for not possible. You wouldn't want to leave it blank because then it looks like you just didn't know the answer. So it doesn't exist. -1's not in the domain. That's why it doesn't have a y. And what's f of -3?
2.5.
Yeah, about 2.5, 2.5. You can write it either way on that one. Now you've got, I think you've got 3 of these. Let me go ahead and tell you while I'm at it. I don't know why I didn't give graphs last year, and I added a page of graphs, but I didn't know how to put those 2 PDFs together to make one document. So when you click on classwork, there's going to be 1 through 6 is what we're fixing to do, and then 7, 8, and 9, which are these. So you'll have to click on 2 links to get all of your classwork. So number one. Now we're going to look at them as the equations, but we're not putting the graphs on the graph paper. If they're not going to look like this, I'm still going to ask you about the domain on the first one, but I'm not going to make as big a deal out of it as I will when we get to the graph, when we start graphing them ourselves. Now, the way the notation is, they put a big set bracket, and they put whatever functions 1/2 x minus 2. And they'll put, and sometimes they use commas, and sometimes they use the word if x is less than or equal to 4, if x is greater than 4. And this may be a light bulb moment. This may be one of those you're like, okay, I got to think about this. And then it's like, an aha moment. I get it. I see what she's saying. We will only do linear piecewise. In this case, this is a line. If I just cover this up, that's an infinite line, domain range, all real numbers, all real numbers. Another line, all real numbers, all real numbers. But they set it up as a function, which means the y's can't repeat. So you can't have any overlapping. And I want you to look and see well, here's what I told first block, and I'm not second block, but I'm not sketching it on X and Y graph paper right at the moment. But I know this one has a domain. It's a line, and its slope is negative, so I know it's going to be coming down, and it's going to actually, at positive 4, it's going to have a solid dot. And then this one's going to be going up. Now, I'm not exactly sure where my y and x intercepts are, but I do know that at 4, it would have to be an open dot, and it would be going like up this. Something like that's what that graph would look like. Is the domain all real numbers?
Yeah.
Yes, because it's, at whatever this point is, which is 4, you have a y, and you have 1, and then you have infinite x's over here, infinite x's over here that all have 1 y. So this is a function. Domain is all real numbers. Not worried about range. It's easier to do like you did on quiz today when you've got the graph. Because at this point, I don't know exactly where my intercepts are and stuff like that. But just to give you a little bit of feel for it, I'm going to erase that because it's in the ballpark. It may not be exactly. Now, we're just doing what we did the other day that I just showed you, where we're doing the ordered pairs, kind of like we just did up here. So I want to know what f of -1 is. I want to know f of 4, f of 0, write these down, f of 7, you got to know the notation, and f of 8. And I would encourage you in classwork when you do them, not just to give the number, but give me what it is, f of whatever, and I'm going to show the work, and I need you to put the work in your notes so that you know what we did. Now, what decision you have to make first? All of these numbers are in the domain. We said the domain was all real numbers, but we have to figure which piece, just like up here, you had to figure out, was it going to be on this line, which is a horizontal line, or was it on this line? That's what you were asking. When I did f of, was that my -3? And we had to figure out, was it this one or this one? Well, that's what you have to do here, but you're doing it by algebra rather than doing it by looking at the graph, a visual thing. So where is -1 in terms of my domain? Is it less than or equal to 4, or is it greater than 4? Less than or equal to 4. So I know that -1 is going to be on the line that's coming down, so I'm going to put -2 times -1 plus 8. I know it's on that piece of the graph. We do the arithmetic, that's 2 plus 8, which is 10. Now, I promise you, you don't have to show this in your classwork. It's not a bad idea, because then if you have a mistake, we can catch where the mistake is. So if you were to graph it, then you could look at -1, and you could go up your blocks, and the y would be at 10. The point -1, just like this, -1, 10, either in t-table form, or ordered pair form, or function form, is on this graph, on this piecewise function. F of 4. Now, where is 4? Is it on the top one or the bottom one? Top one, because it says equal to 4. So again, we put -2 times -4. Oops, that's positive 4, isn't it? Plus 8, which will give me -8 plus 8, which is 0. Now that is actually your x-intercept. Because look, in the 0.40 over on the x-axis, that's where this graph, just like these, see, this right here is your x-intercept. In this case, this would be where the whole thing crosses the x-axis. Kind of seeing what we're doing? So what about f of 0 if you were doing it? It's just looking at it in the terms of the equation, like these. If we knew their equations, we could just plug into them. And we could actually figure those out. I haven't taught that lesson. You'd have to get the slope, you know, count your rise and run, get your y-intercept. I usually don't teach that. I either read the graph or we graph them ourselves, but I've never had you go from here to here. I just haven't done it that way. So where is 0? Is it on the top part or the bottom part? Where is 0 in these numbers? It's less than or equal to 4. So I'm going to again put -2 times 0 plus 8, which is 0 plus 8 is 8. And that is your y-intercept. See, when x is 0, y is 8. The bottom two, if you look at 7, is 7 going to be on the top one or the bottom one? Kyle. Okay, tell me, where's 7 in terms of these two numbers? Is it less than or equal to 4, or is it greater than 4? Okay, 7 is less than 4. Okay, it's greater than 4, so we need to put it in this one. Now, we're going to stop right here. Well, actually, I may go ahead and do this, because this is a good thing for that lesson for when you get ready to have that quiz. So we put in, I should have gone and put it in, 7. And depending on how you type it, it'll either give you 3.5, let me try that again. It'll give you 1.5, because it's 3.5 minus 2, 1.5, or it gives you 3/2. And why I have never figured this out, I don't know. And here's the deal about that. Do you know when we've been using that alpha x key? If you use the alpha x key, and you can just do this on your home screen. So if you go to your home screen, and if I type this, because I've been looking at mode and I've been looking at format thinking it was a key that you push there, but it's actually the way you put it in. If you use, when you're graphing, the fraction like alpha x, 1 over 2, arrow over, times 7, minus 2, it will give you the fraction answer. And you were getting the decimals, Jude. So if you'll put the fractions in, it'll give you those fraction answers. You don't have to mess with rounding. I put on the quiz round to 3 decimal places if necessary. If you do them to decimals, you have to round them to decimals if they don't come out. And then, or if you do it like we did it in lesson 4, the first one, 1 divided by 2 times 7 minus 2, and look, so you get the 1.5. I just never thought about it. Put it in with the alpha x key and it'll give you the fraction. Put it in just straight across with using the division bar. So if you go back and look at your lesson 4, I wouldn't necessarily redo it, but that kind of helps. So where is 8? Less than 4, greater than 4, where does it fall into this? Bottom one, 1/2 times 8 minus 2, that's 4 minus 2, which is 2.